3D Printing Today, show number 422. 3D Shook, changing settings on old Marlin. More materials we forgot to mention.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, it does not matter. We cover it all. My name's Andy Cohen, and I'm here with Mr. Whitney Potter.
How you doing, Andy?
I'm doing pretty good, but I think the folks at Ascentium are not doing very well.
No, it seems like things are not going so well for them. Their SPAC, which is their Special Purpose Acquisition Company, their SPAC deal fell apart.
Yeah, and we want to say sorry, pal, to one of our friends out there, Kurt, who worked for Ascentium in Irvine. He lost his job.
Oh,
and that's kind of how I learned about this. And then I went digging around, and there's an interesting article on 3D printing industry about it, where they kind of look deep or attempt to look deeply into what happened here. And they really don't have a reason for its falling apart. All they can get out of Ascentium is that the market situation, the stuff happening in the market, and you can assume, based on reading the paper, that it could be Ukraine, it could be what else could it be? It could be inflation.
Well, there was a massive stock market crash last week,
which may have been related to Ukraine or inflation.
Right. Yes.
But they won't really tell us. But and then later in the article, there's an interesting speculation about how certain academics kind of predicted that the whole idea of the SPAC may have fallen apart. I mean, when you do a SPAC, what you're doing is you're doing an end run around all the work
the regulation
that's supposed to go into an IPO. Basically, You're cheating.
Sure.
And it looks like when that happens, the gamble is actually being made mostly by the company that's got the cash,
fronting the money. Yeah, sure, yeah,
not the company that's got the value. Is the company that's got the money, and they're taking all the risk. And we can make certain assumptions that this particular company. Let's see, what was the name of the company that they were merging with? Atlantic Coastal Acquisition.
It was just a SPAC. But I mean, they're both taking risks, right? Because the SPAC, right, which is the money side of the deal, is gambling that when they take the 3D printer company public, they're going to be worth more than they paid for it,
right? And they must have put some money into this initially,
right?
Because in the article they say if anything happens and they make out with somebody or something, that this Atlantic acquisition company, Coastal Acquisition, gets some money out of it.
Right, they get a payout if Ascentium is bought by someone else at some point in the future. So
which could easily kill that deal.
Right. So so it's an interesting questions. I mean, obviously both of them think that they're going to make money on this deal, right? I mean, the money people wouldn't be putting in the money.
If the SPAC continues and goes through.
Right, if it works. But I mean, there is some expense in setting things up.
So it's a safe inference that if it doesn't work out and the SPAC breaks up, that one of the pair, and they're saying here both, but I doubt it's both, one of the pair says, I don't think this is going to work, so we're bowing out. And my bet is it's the guys with the money.
Well, you'd think, but it depends, because I mean, it's the guys with the company. I mean, they got to look at what they're selling their company for, and if this merger is going to happen in a very uncertain market, then they may not be getting the price for their company that they're looking for too. So
well, let's take a look at Ascentium and its added value, which we've never really talked about. Ascentium is an FDM company, an FDM based company, and they may have other versions of 3D printing. I just don't see articles about it. And it seems that they are that they look at FDM kind of like some companies like Markforged have done, where they say it's a no compromise, sensors everywhere, constant adjustment, for the optimal output. You know,
A completely enclosed heated build chamber.
Right. Yeah. And
so super high end.
And it looks like their markets are, or their market is DoD.
Uh-huh.
And one can assume, and I think it's a bad assumption, that if you've got contracts with DoD, you're made.
Right.
And that's probably not a good way to go. And maybe this acquisition company figured that. Who knows?
Yeah. Yeah, I don't know. I mean, it seems like the fact that you can get a DoD contract speaks well of your technology, but it doesn't necessarily guarantee the profitability of your company.
Well, speaking as a one-time DoD contractor employee, it may speak well for their ability to do paperwork.
Okay.
So I don't know about that, but I hope the best for them.
So you're saying you put over a lot on the DoD?
Yeah, you can. So I hope the best for them. I hope it works out. We'll see what happens. In the meantime, what's on our show this week, Whitney?
We're going to start out talking about 3D Shook.
And then we're going to look at changing settings in old Marlin.
And then we're going to cover some more materials that we forgot to mention.
Okay, let's do it. So this is a redo. I deleted the previous episode, the previous recording of the segment. We're going to redo this segment because after we recorded the 8-minute segment, we dug a little deeper and we realized this needs to be represented a different way. So because of our discussions of Thingiverse, we decided we were going to start looking at other thing depositories or repositories, or places that you could go find things to print. And we found this website called 3D Shook. 3dshook.com. We went there. We took a good look. Looking at it, and my first blush when I looked at it was it's kind of like attempting to be like My Mini Factory and Thingiverse, where they've got categories of different things such as toys and household, DIY, other things that are up there. And the moment you see the little images of 3D printed objects, not renderings, but the actual print of the object, which is a good thing because you know it will print. You see the prices, and there's pricing on each object that you can download. And the prices range from like $2 to $9 as far as I could tell.
Yep.
And so I'm trying to figure out, what is this business? What are they doing? Is this a Thingiverse replacement? And at first, when we did this segment, we thought it was, but it's not.
No, it's actually a collection of 3D printable objects that was created by a company.
Right.
So there's no way for you to add your designs, for you to upload them. This is everything that's on 3D Shook is designed by their in-house design team.
This is a business that sells printable objects of many categories.
Yep.
Now, we've covered similar websites and plotted them, such as the one company that makes radio control automobiles that are really detailed and very complicated kits. There's one that does radio controlled airplanes. There's one that Fab 365, which does toys that are foldable, that print flat, brilliantly designed objects. And I don't want to say that 3D Shook misrepresented themselves. Absolutely not.
They've not.
They have not done that. But it's not at all a Thingiverse replacement. It's a for sale, objects for sale made by their designers.
Yeah. And they've got talented designers, and they've got some nice objects. They don't have that many of them in comparison to one of the crowd sourced sites like Thingiverse or
My Mini Factory,
virtually any of the other ones where you've got just all kinds of people around the world sending stuff in. But yeah, it's an interesting model, to have in-house design team actually create all of the objects.
There are some things about it that are kind of odd, like that time thing. How does that work? Somebody asked a question.
Yeah, in their FAQ, this is interesting. The question is, can I download models and print later? And their answer is yes. However, we are an all-you-can-print service, not an all-you-can-download. There is a download time limit based on calculated duration of average print, which sounds to me, now maybe I'm not interpreting this correctly, but it sounds to me that they're saying that if you download something that they think is going to take 3 hours to print, they won't let you download anything else for the next 3 hours because you're supposed to be printing that object.
Interesting.
That's is the way I'm interpreting that. Maybe I'm all wrong on that. I don't know. But anyway, it's interesting. It's an interesting model. You can read up on their design team. They're mostly recent industrial design graduates. I'm not sure where they are, judging by names. I'd say somewhere in Eastern Europe, maybe. And I'm not. They're names that are definitely not your average, standard American British names, but not. They're all Caucasian, Eastern European, maybe. Who knows?
Yeah, but I like the idea of what they're trying to do, but there's an analogy here that may hold, and it's one thing to have a music service, but it's got to be music you want to listen to. So imagine if Spotify only played music made by, say, 6 bands, and nobody had ever heard of the bands before.
They were all the Spotify house bands.
Yeah, and the music was kind of like, it's okay, I guess. I mean, would they make money? Probably not.
Right.
Probably not. So instead, Spotify's open to literally any musician.
Yes.
And there's some rules that they have to apply, and
like you won't get paid, Jack.
Yeah, you won't get paid much, but that business model seems to be working really well. Spotify is now the music source.
Yep.
Will this work? I don't think so, and not unless their designers are brilliant. And can come up with incredible stuff that they can make a lot more money with if they just simply produced it.
And I'd say their designers are as good as any designers anywhere in the 3D printing world. It's just that the model of having a limited number of designers producing a limited number of products, it's kind of like a bricks and mortar store trying to compete against Amazon. It's just the selection just isn't there.
Yeah.
So it's just
I think a better model is when you focus what you're making.
Yeah.
Instead of all these categories. Follow the lead of, say, the company that makes the RC cars.
Right.
That's all that they produce. They don't produce planes or rockets. They're just RC cars.
Right.
And they're
incredible.
And they're incredible. And there's only maybe 6 of them. So what?
Right.
If you're going to 3D print a model of an RC car, you're going to go to them.
Right.
Maybe that's the better approach rather than this. Whatever you could think of, whatever you can design, when we're going to put it into a category, kind of like a Thingiverse or My Mini Factory, I just don't think you can populate it with enough quality stuff to make it worthwhile.
You can't if all of the designers are employees of the company and are drawing a salary on the company for the time that they're taking to design it.
Yeah,
I don't see how that's ever going to work.
You'll never make enough money.
You could have partner designers. You could sort of curate, people around the world producing quality products, and do sort of, the My Mini Factory version of it, where you're kind of curating a collection of designers in addition to a collection of products, and then offering them for sale. And that seems much more viable because you can have a much larger selection of
as long as you can get all those makers to contribute. That's the key. If you can get the people on Thingiverse to, a good maker on Thingiverse to put it on your site, that's great. But you've got to go do that. You've got to bring them in. Yeah.
Well, actually, My Mini Factory did that years ago. They with my permission, scraped all of my stuff off of Thingiverse and put it on My Mini Factory. And I was like, yeah, okay, I'm happy to support. And it's none of it's for sale, but they were just building their collection of stuff. So I was happy to participate.
Yeah,
didn't take any effort from me.
As long as they ask for permission. information, I'm okay with it.
Sure. Yeah. But looking at this, I mean, you've got the total number of designs. I mean, these are quality designs. Not every one is something you're going to want to print. But they're definitely. If you were going through Thingiverse and see these designs come up, people are like, oh yeah, that's a good design, but there's probably fewer of them than would be added to the Thingiverse in an hour.
Yeah.
Yeah. Now, granted, I think somewhere around 98% of the ones being added to the Thingiverse are just utterly useless.
But the fact is that it's a constant flow of constant things. Within a day, you'll have at least half printable, interesting things of what they've got on this website in one day.
Yeah.
So I don't know.
So yeah, it's difficult for a dozen people somewhere in a studio to keep up with that.
Yeah, very.
So, anyways, I wish them luck. It's interesting. I mean, you can buy individual things. You can subscribe. And get a certain number of downloads as a package, or download a certain number of downloads a month. There's all these different ways to do it, but it just the collection just isn't that enticing to me.
No.
But and they haven't updated their website copyright since 2015.
So it could be fallow for all we know.
It could just be coasting along, processing your credit cards.
And they all got jobs. They all went out and got jobs.
Probably.
Yeah. So I admit I don't really operate much with old school Marlin. I do have one Mendel machine that I use. My son's got a Mendel machine upstairs. He's got the CR6, I think it is. I've got an Ender 3. My Ender 3, as if you've been listening to the podcast for years, you know that I blew the board on my Ender 3. So I've got an SKR Mini in there, and it's got things in the menu that you may have set in this way that we're about to discuss. So I'm going to admit right up front that, this is not something I do a lot, but the question came up on the Google group. A friend of ours, Ray Price, has a CR10, and he's showing issues that he's getting with corners of boxes that he's printing. Little ripples are coming in the print. Mm-hmm. And he goes online and he says, "What's this from?" And I said, "Well, in my opinion, it's speed. You're going way too fast. What's your speed?" And he said it's 80 millimeters per second, which is twice the speed you should be doing on a Mendel. Mendels are usually 40 millimeters per second starting, and some things you can go as high as 65, but 80 is really pushing it. That bed's got a lot of mass, and you're going to get a lot of backlash on that mass as you change directions. Anyway, so I'm looking at it further, and the question of which slicer came up, and he questioned, well, can I do this in Prusa slicer? And a user also came up on there who's he talks like he's one of the developers of Prusa slicer, but he's probably just a heavy user. Mm-hmm. And he said you could do this in Prusa slicer. So Ray tried it in Prusa slicer, and he fixed a lot of the problems, but now the problem's happening in another corner. So that made me think, well, what's happening here is that the acceleration on the feeder stepper of the extruder, it's not coming up to speed in a pragmatic manner. In other words, the drive gear in the stepper motor of the feeder of the Bowden extruder of the CR10, it's going too quickly to full speed.
Too high acceleration.
And so you get this kind of effect in the compression of all the material in the Bowden tube. Yep. So I mentioned that on the forum, and you guys can go see that if you go up there. And so Ray says, well, okay, how do I? I said it's probably acceleration. Try upping acceleration for that stepper motor. Mm-hmm. And he said, well, how do I do that? And I go, oh, wow, yeah, it's Marlin. It's 8-bit Marlin. I don't know. There's no menu for it. There's no config file for it. Ouch, you've got to go to the source code, right? Uh-huh. Wrong.
No.
And I should have, and I remembered this because of all the hassles I went through with the iFactory.
Oh, okay.
No, you don't have to do that. You tether your printer to your computer and run a slicing software. I use Simplify 3D for this.
Right.
And you
open the terminal.
Open the terminal so you see what G-code's going back and forth. You get your window up there. And you send a G-code command, M503.
Okay.
And M503 will then tell the firmware to say all your settings. Dump your parameter settings, the stuff that's saved in the EEPROM. And you should see what it says for acceleration, so you know what your acceleration is. And then you send the G-code command for acceleration. I forget which one it is. It's in the 500s, I know that. And then it changes it, and then you have to save it with an M500. And then you do an M503 again to make sure it changed it correctly.
Right.
And then you test it. So for those of you out there who have one of these older controller boards, the 8-bit controller boards, you don't have to go to the source code and make the change and then recompile and then send it up there with bootloader. That's a lot of work, a lot of tedium. Try this instead. And then you can quickly test it and then change it and test it and change
iterate much faster.
Yeah.
I remember doing something similar to that when we had, you remember the printer bots?
Yes.
They had a little inductive height sensor that was sort of their version of bed leveling. And you had to set an offset value, and you had to punch it in with a whole bunch of M codes.
Right. Right.
Yep. Yeah. As long as you got the right codes to do, it's not that hard.
Yeah. And chances are, Ray's problem is related to that immediate compression of the filament in the Bowden tube, and it's pushing it out a little bit too fast, and then it's a little too slow, and then a little too fast, then a little too slow, and that's why he's getting those little bumps.
Right.
That's my thoughts on it. It could be something completely different, but I would check that out. Up acceleration.
I would reduce the acceleration.
Well, the higher the number, the more. So
the more ramp up time.
The more the ramp up time.
Okay,
that's what I mean. So that's an important point to understand.
That is, yeah.
The lower the number, the faster it gets to full speed, and the faster it breaks.
Okay, so this is delay time.
Right.
Basically?
The higher the number, the more time it takes to get up to speed, and the more time it takes to slow down.
Gotcha.
So if you're listening to it, it sounds, the higher the number, the more it sounds like.
Right.
So you get up to speed and you slow down.
Right.
So you get a really high number, you'll get that sound. If it's a real low number, you won't get that sound, and you'll get a lot of rattling in your gantry. Things will rattle a lot because it's starting and stopping really quickly. Yeah, you're going to get a lot of effects in your print as well. So overshoots, ringing. The higher your acceleration number, the less likely you're going to get those kinds of after effects. It'll also print a lot slower.
Right. Yeah.
Since we have a community of our own, on the Google groups, we get instant feedback on each show, which is great. And we hope that you guys out there will consider joining it. It's a really cool community. It's not filled with people that like to troll, because we do watch over it, and there's no flame wars, and we try to keep it as eclectic as we can. And anyway, so we got comments back from a few of our friends on that forum about some of the materials that we forgot to mention. I knew there were some. I just knew it. So we're going to review those that we have experience with and some that we don't. And let's start with the ones that we have some experience with. And the first one is HIPS, which I believe stands for High Impact Polystyrene.
That's correct.
And HIPS, I've gone through about 3 spools of HIPS, so I have a little bit of experience with it. HIPS, when I started using HIPS, I was under the impression that, hey, this is just like ABS, but better. Until I got about halfway through the first spool, and then I realized, no. Well, it's like ABS in that it really stinks chemically.
Yeah.
Really, really bad chemical stink.
Styrene is nasty.
Yeah, it outgasses really badly. It also shrinks more, in my experience, with ABS than ABS.
And And if it shrinks more, does it peel off the build plate more?
Yes. So you have to work harder and keep it softer for longer.
So we'll keep it warmer.
Yeah, you got to keep it warmer. It's got to be fully enclosed. And at first I thought the aesthetic was an improvement. And as I printed with it more and more, I found the aesthetic was not as nice as regular ABS. And in the end, I gave up on it.
It didn't look better, and it wasn't easier to print.
Nah.
Okay.
And it breaks. It's like super
brittle.
Really brittle and really easy to break it. Mm-hmm. In particular at the fusion, the layer lines, no matter how hot you get, you do have to go a little hotter. In the end, I think the only real value of HIPS, and I think those who use it out there may agree, is that its use as a dissolvable support material with ABS, and it'll dissolve with limonene, from what I understand.
Yeah, I think you could probably dissolve it in acetone as well. Styrene
not surprised.
is soluble in acetone.
Yeah. So, and from that perspective, it's probably the best of the soluble or dissolvable support material, because the next material we should talk about is PVA. Mm-hmm. PVA, which is primarily a dissolvable support material. I don't think it's used for actual 3D printing at all. This stuff, it dissolves in water. Mm-hmm. And
that's polyvinyl acetate,
I think.
Okay.
We're not going to attempt to describe the actual chemical meanings of the initials because sometimes they're just impossible to say. But in any case, PVA as a printable material is incredibly difficult to print with. It's not deterministic because it'll drool out and get all over the place, and you can't stop it. And I've tried printing with it before I tried using it as a support material, and I found it very difficult to work with. If you're using it as a support material, of course, all you care is that there's enough there for it to build upon, and then to put a solid layer before the surface of the actual object. And I found that kind of tricky to do. And then you add to that the problem of how hydroscopic it is. It sucks up moisture out of the air really quickly, and when it does that, it expands. So the moment you take it out of the sealed bag, you really got to use it all up, because really quickly it will no longer be within tolerance of your feeder diameter, and you'll get a clog. And I saw that repeatedly. So the idea with PVA is never buy a spool of PVA. You buy a couple of loops of PVA, and after you've used it, if you can't vacuum seal it, it's a goner.
It's done, yeah.
It's finished.
And to top that off with, it's usually quite expensive.
It's pretty expensive. HIPS was actually pretty inexpensive, which was why I decided to give it a shot. So I was surprised at how low cost HIPS was. It's probably cheap because they couldn't sell it. Anyway, so let's go to our next material, which is PVB. Now, PVB, I got a special deal during the holidays to purchase some PVB at a discount, so I went and I ordered a spool of gray PVB, and I do have a little bit of experience with it. I printed the iconic XYZ Cal Cube.
Oh, sure.
And if you look at it under the light, the layer lines are a little bit awkward.
Yeah, it's a little strange. Little loose, kind of.
Yeah, and it doesn't have a very great aesthetic.
Yeah, not super high tolerance.
Yeah, and it smells. The moment you take it out of the bag, don't take it out of the bag in your room, in your house, because it's gonna really stink it up. Take it out of the bag where your printer is, hopefully in a well ventilated or outside in a shop somewhere. Mm-hmm. It's not as bad as, say, PVA, but I look at it and I wonder, well, why? It's a little more expensive than PETG and PLA, and it doesn't really feel that much stronger. Here's another example where I've got it tuned a little better, and the layer lines are quite a bit cleaner.
Yep.
And you'll notice that the layer lines are not as prominent, so it kind of fuzzes up the layer lines, which is a good thing. Mm-hmm. And we'll be experimenting with PVB quite a bit more and talking about it in detail in its own segment.
Yeah. Now it's one of the ones that you can
Dissolve.
you can
You can dissolve it with isopropyl alcohol, known as
Gotcha.
IPA.
right.
So it works well with ABS.
Oh, that IPA.
Yeah, that IPA. We got to be careful because here IPA means something completely different.
Right.
Something that you drink.
Do you use it for soluble support, or do you use that functionality just to vapor polish it?
I'm going to try vapor polishing. I'm going to see how it works out.
Cool.
But, be that as it may, the layer lines themselves, once you get it tuned nicely, the aesthetic is different from any other material. So we'll be experimenting with this more, and so the jury's out.
You'd think it would be tough because the primary use, this is polyvinyl butyrol, and the primary application for it in industry is it's the layer of plastic between the two layers of glass in a laminated windshield.
Right.
So it's the part that holds the glass together when it gets spiderwebbed by your forehead.
Yeah. Hopefully not your forehead.
Hopefully not your forehead, but you know what I mean.
That rock that hits your windshield as you drive by.
Yeah. So it's extremely tough stuff, at least in very thin films. How it performs in large chunks could be completely different.
We're going to find out. We'll be playing with it.
Definitely.
Okay, so the next filament is one that we've ordered it thanks to inputs on our forum. It's called PP, which is actually one of the most popular industrial plastics and polymers out there.
It's polypropylene.
Polypropylene. And yes, they do sell it in 3D print filament sizes. We've ordered a spool of it. And by the way, I want to mention PVB only comes in white, black, and gray, whereas polypropylene comes in white and natural. I haven't seen it in other colors yet, but they may be out there. Again, we're going to find out just how useful and how much does it really make sense to move with polypropylene. One of our friends on the forum actually uses it quite a bit in his business. He produces parts with it, and he's the individual that let us know about it. When we get our spool and we do a detailed review of the entire use of the entire spool, we'll mention all the feedback and all the folks that have told us about it.
Sure. Yeah, that sounds like a good plan. Yeah, polypropylene it's funny because I think of polypropylene. I mean, as a backpacker, I think that's what backpacking clothing under garments and stuff used to be made out of. And I just remember how bad it smelled after a week.
Really?
And nowadays they've sort of improved the formulation. A lot of those garments are being made out of polyesters rather than polypropylene. But we still kind of generically call that. Oh, you got your polypro? Just put on your polypro,
Don't they make pipes with polypropylene?
They may. The primary use of it that you see in your house is when you buy like a yogurt or anything else that comes in a plastic tub, sour cream, cottage cheese, any of those plastic tubs from the grocery store. Most of those are the ones that are not transparent are polypropylene. The transparent ones are PETG or PET at least generally. So.
Okay, so we've got one more that we haven't really talked about, and we probably will never get to try because I don't think any of my 3D printers can handle this stuff. And that's PEEK.
Yes.
P-E-E-K. It goes by another name. Also, it's commercially known as Ultem.
And we've actually used that as thin films of that as a printing surface. Right?
We've tried it. We have tried it. I've used PEEK in my job. PEEK. One of the really awesome things about PEEK is that you can produce it in a low tolerance like mold or 3D print it, and then you can put it into subtractive methods and get it to tolerance, which is what we used it for as an experiment in one job that I had in the past. It's one of the most durable, rigid polymers out there. But it needs an extreme amount of heat to get it to liquefy.
Like around 400 degrees C.
Yeah.
It's funny because I remember some of the early generation hot ends had used PEEK as an insulator material in it.
Yes.
And that was usually the first part that failed, so it wasn't that good at doing that.
I'm pretty sure the printer bot, and there were a bunch of them that we had, idea maker. Was that
the original
Idea
hot end on
Tech or whatever they called it.
Yeah.
And I think there are still companies out there that do make hot ends with Peak. I don't recommend them.
Yeah, no, I don't either, because it's a part that you're going to have a hell of a time replacing, other than just buying a replacement part from the manufacturer for whatever they choose to charge you. So,
But Peak as a 3D printable material, I would love to be able to 3D print Peak, and maybe someday we will. I do have a handful of machines that are powerful enough to do it. It's also quite expensive, as is PP, polypropylene. Polypropylene is pretty expensive. PVA is pretty expensive. I think of all of these, PVB is not as expensive. But it's not as cheap as PLA, and HIPS is probably the cheapest of all of them.
And Peak is positively ridiculous.
Yeah.
I'm looking at one source here that is offering to supply it for $295 for 250 grams of it.
Wow. Doesn't it also go by PEKK?
Could be. I'm looking at PEEK, polyether ether ketone, but you could probably connect your ethers and ketones in different ways and get different variations, it being a polymer.
So these are all kind of out there, not very popular materials. Honestly, at this point in time, I don't really recommend any of them because my experience with them is not that detailed.
Unless you have a really specific use case that requires one of them, which, I mean, that's, it's good to know that they're out there.
But we'll be talking about polypropylene next time.
Excellent.
Oh boy, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed. To all of our very supportive listeners, thank you all out there for your support on Patreon. Thank you for your good reviews wherever they're made. And hey, thanks for listening. We do it for you. We do it for fun. We're not in this for the money. Unlike Frank Zappa, he's in it for the money. Or he was. He was in it. Right. Okay, so thing of the week. And I got to tell you, folks,
this is hard to find a good thing of the week.
This week we had trouble finding a good thing of the week. And in the end, this was kind of like, well, okay, it meets my criteria. It's easy to print. It's useful. It looks kind of cool. So what the heck? Your thing of the week. And we're talking about the bottle dryer. It's on Thingiverse again. The bottle dryer, 720 degree thermos, etc. I have no idea what that refers to.
I think that's the different brands of bottle you could dry with it.
Could be.
But you could dry just about any bottle. Like I tend to reuse, single-use water bottles, and they would work fine with this.
Yeah. So. It's basically a little stand that lets the water drip out without letting any of the stuff that's on the plastic get in. And it's small, easy to use, and if you keep a water bottle on the side of your sink board, it's probably a good idea to use this. It comes to us from a maker on Thingiverse whose handle is K-I,
otherwise known as Kai S from Germany.
And it looks pretty easy to print. Nothing special about it, and it does look kind of cool. I guess that's it. If you've got a question, a tip, or hopefully a candidate thing of the week, send us an email.
You got any good ideas?
Yeah, we're looking. It's this right now. It's getting a little tricky. So we need your help. Send us an email.
Send it to info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
And again, we invite you onto our forum. Go to Google and search 3D printing tips and tricks. And when you get there, if you want to post, hit that join button and give them any email. It's an email you're going to need to get to because you may need to verify that you are who you say you are. Let's see. We do have a show next week. Show number 423. Hopefully we'll have a thing of the week for that show.
Right. We start out talking about pellet extruders.
We discuss the enraged rabbit material switcher.
The enraged rabbit.
I could just get this image of a really angry rabbit shoving filament into an extruder. I just don't know.
And then we talk about fixing the massively non-manifold.
I guess that's it.
Great. Thanks for listening.